Okay. Do you see my screen?
Yes, sir. Yes, sir.
You can see. There is a problem. There is a red border that comes. It's not coming today. I mean, right.
But we can see your screen. We see the slides.
Okay, then it's fine. I don't know what this. Where did this red border go? Even in the morning it was coming, but anyway, if it works, it's fine. Okay, then let me switch to the presentation mode. Okay, so what we started in the last class, that is last to last week, was a section on text processing utilities, and we have covered only how to write regular expressions. So now we will embark on some, I would say, utilities that can handle regular expressions and do other things as well. Okay. To start with, I will talk about grep, G-R-E-P. Today also I want to cover something called SED, SED. Next week we will cover something called AWK or GAWK, awk. Now that awk is a full-fledged programming language, so we need to look at it more leisurely. So we will do it in the next week. So what is grep? It is basically an abbreviation for global, G, regular expressions, RE, print, P. Okay. So this is similar to a visualization program like LESS that shows you the lines of a file that matches a regular expression. So it's essentially a utility devoted to regular expression searches. Okay. And it actually prints all the lines that contains matches of regular expressions or some other things. Okay, I will come to that slowly. And it locates lines that contains matches of regular expressions that you provide in the command line. And it may or may not highlight the match. Unlike in the previous examples, as we have seen here, this is highlighted. Okay, but if you run this grep and supply the same pattern, it will print this line, but not necessarily highlighted. Depends upon your shell and other things. If certain options are set, it may be highlighted, it may be not highlighted. Okay, but anyway, you can see all the lines that match. So it's essentially the same tool as we have seen in the last class. I mean, finding that lines that match, or actually that do not match is also possible. Okay, but the point is that there are many, many options other than just visualization that grep allows you to do. And these are the things that we will learn in the first half an hour or so of today's class. So in command line, you run this grep as grep, this options. This is the important thing. Okay, this is followed by that regular expression, which I call pattern, followed by one or two files, or if you do not supply any file, grep will wait for you to enter everything. So it's essentially std in. Okay, so the pattern is a regular expression. And before going further, this is I would say, this is an advice. A regular expression may contain characters like star, dollar, and similar things that have special meanings to the shell. Okay. So it is always advisable that you quote this pattern. What kind of quote will you use? Actually, if you see, look at your keyboard, there are three types of quotes: single forward quote, double forward quote, and single backward quote. Okay, never use this backward quote. And the forward double quote, or just double quote you call it, this also has some problem with the shell. For example, if you have dollar, shell will try to replace that with some, evaluate that thing with something. We will look at this when we study shells. So single forward quotes are always recommended. And what about backward quotes? This is something that you will learn when we talk about shells. Never use backward quote in a shell unless you know what you are doing. Okay. And also, of course, quoting also enables you to search for patterns containing space. So that's another important thing. So let's quote it. So I will use single quote in all the examples that I will provide. Single forward quotes. Okay. So this is my text file that I have been using in the last examples, last set of examples as well. So whatever it is, it doesn't matter. It's just a text file. So let us see how I can run grep. First of all, this regular expression. Okay, here I have no options for grep. Okay, you do not see any options. I just give the pattern and the file name. In this case, the file name is called textfile.txt. And grep will print all the lines that contains this pattern. In this example, this is not any regular expression. Of course, it's a regular expression, but it's also a literal string. And I have not quoted it. Okay. So you can see this line is printed, method, whichever line contains method, it's printed. Now, if I want to find lines that contain method followed by a space, okay. If I do not use this quote, I cannot tell grep that I am also including this space in my pattern. Okay. If I use the second space here, it will be considered as a separator. Multiple spaces, they basically constitute a separator. Okay. So in order to let grep understand this space is intended, I have to quote it. Okay. So, and this line is not printed because this is not followed by space, but by dot. And some other things you will see. Okay, that will not be printed. Anyway, and then if I want to do this regular expression search method followed by either a space or dot, this is a literal dot. And if I do not quote it, shell will create problem, invalid regular expression, something like that. But if I just quote it using single quote, there is no problem. Now this is a regular expression standing for method followed by either a space or a period, full stop. Okay. So this is the output. So this slide essentially, I would say, highlights the use of using quotes, why it is necessary, and you can supply further, more complicated regular expressions like this, but don't forget to quote. So this is the output. Okay. Okay, now one by one, I will look at the options, these things. What options, additional options I can provide so that the printing is, or whatever, the output is, I would say, not exactly like this single thing, single pattern search. For example, if I want to make multiple searches, I will print a line if search pattern 1 matches, or pattern 2 matches, or pattern 3 matches. Okay, like that. So this can be done using this -e option. minus E essentially stands for expression. I'm providing this regular expression. Okay. So in this example, I am searching for those lines that contains either the pattern method or the pattern algorithm. And this is the result. So this minus E option essentially gives you searching for multiple patterns, but these patterns have to be understood as or. Either this or possibly both. Okay, so I just leave it to you as an exercise. What if I want to find out the lines that contain both this and this? What should you do? Okay, you think about this. But think currently, if I specify multiple patterns, it's meant or. Either this or possibly both. Okay, for and you have to do something little different. Okay, this is a hint. You can use pipes, for example. Okay, and also there is another, I would say, utility of using this minus E option. Suppose I want to find this pattern minus key. Okay, like this public key, this type of thing. And then if I simply specify this, grep mistakenly identifies it as an option, and it says the option K is invalid. Okay. But if I precede this by minus E, then grep understands that whatever follows is a pattern. This should not be treated as an option. And then it perfectly works. Okay, so these are two ways of exploiting this minus E option. And there are several other options. The inverted search. Instead of finding the lines that do match, if I want the lines that do not match, then I run grep with minus V. Okay. For example, if I write grep minus V, capital A to capital Z, then it will print all the lines that do not contain capital letter, do not contain capital letters. So these are the examples. These are the lines in my text file.txt. So this is inverted search. Okay. This is case insensitive search, minus I option. So if I simply say grep method text file.txt, it will print certain things. And if I want to make case insensitive search, I say minus I, and then you see this line is also printed because of case insensitive search. This is capital M. This line is not printed here. Okay. Okay, so these are just trivial things. I'm just telling you what each of the options do. Okay. This is possibly another important thing. Option minus W. So lines. Yeah. Any question? No, I don't think so. It's just a random interference. Anyway. So if I supply this, then this will print all the lines that contain a capital letter. Okay. For example, this. Here I have I, capital I. And if I additionally give the option minus W, then essentially it will search for single letter uppercase words. Okay, so only this I, this is a single letter uppercase word. This I is the single letter uppercase word. This is also, and only these lines will be printed. This, and this. Okay. Okay, so any other option? Okay, few other options. I mean, you can all figure out what is happening. Minus N option prints the line numbers before the printed lines. The line number in the input file. Line numbering starts from 1, not from 0. Okay. So this essentially tells dollar is the end of string. So print all the lines that does not end with an alphabetic character, capital A to Z or lowercase a to Z. Okay. And if I additionally want to print which are the lines, then I run it with -n, then it will say this is line number 6, this is line number 9, this is line number 11, 17, 19, 22, 24. And if I just want to see how many lines match, okay, instead of the lines themselves, I just run it with the count option. Just count how many lines match. So this is the -c option. So you can see this is 7. 1, 2, 3, 4, 5, 6, 7 lines match. So it will just say 7. Okay. And there is, I think, another interesting fact about grep. You can search recursively in a directory tree, directory subtree. Oh, I think this is a mistake. It should not be comma, it should be dot. So I want to search for all files that match the pattern node pointer, and this search will be in the entire directory tree whose root is dot, the current directory. Okay. And you can see that this matches the current directory /libstack static defs.h. This has this node p, stack.h has this node p, and so on. Okay. And what is this? Okay, this is another option, -l, list only to print the names of the files that match. It's not just counting. So here you see defs.h matches, stack.h matches, q.h matches twice, but it will just print it only once. Defs.h matches in shared directory, subdirectory. Stack.h matches, q.h matches twice, but it just says once. So these are the files that match. Okay, so this is nothing really, I would say, complicated. There are some options. And in addition to these basic options, there are many other options that you can investigate from books or man pages and so on. So I will now switch to grep, to SED, the stream editor, which in addition to, I would say, finding patterns, can do a lot of things on the selected or unselected lines. But before I proceed, let me understand that you have no queries.
Sir, can you once again say what is the use of -r here?
Recursive. Okay, so let us see. I am just giving a single file name, or maybe text file 1.txt, text file 2.txt, and so on. Okay. If you say just this recursive and give a directory name, okay, then all files in the I would say directory tree whose root is dot will be searched. Is it okay now?
Oh, yes, sir.
Okay. It's not in this file. Go to subdirectories, go to subdirectories, go to subdirectories, and so on. Explore the entire directory subtree rooted at this, and print all the matches or list the files that match. Yeah. So anything else? Yes, I don't think there would be much, because this is just a listing of the options and what each option does. Fairly straightforward, right? Under the assumption that you know how to write regular expressions. Okay. If there are no questions, I will go to the next item. Okay. Okay, so let me go to this. So this is once again a utility which you can run from the command line. And this SED is basically an abbreviation of stream editor. Okay. Processes the input, maybe standard input or one or more files, line by line. Okay. So the idea is this: set you can give some selection criteria by which lines are selected. Okay. And some processing is done only on the selected lines or the unselected lines. Okay, I will come to that. For the moment, let's say selected lines. And can do a limited set of work on these selected lines. Okay, it's not a very good, huge, I would say, listing of things that it can do, but some limited primitive things that it can do on the selected lines. And unless you specify a file name for its output, the output is the selected lines are printed to std out. Not exactly, I will come to that later, little later anyway. But don't have any, I would say, illusion that the input file is modified. No, that is not the case. Okay. You can send the output to some other file. Okay. And if that happens to be the name of the input file, then I don't know what it will do, because if the input file is the same as the output file, the behavior is undefined. Okay, file gets corrupted. What will happen, I don't know. But as such, it is only meant for printing to std out. It does not modify the input file or files that you specify. Okay, remember this. And then you have this way of running sed. So set options. Some of the options we will see, like grep. Then instead of a pattern, you now have to specify some other things. Okay, of course there may be a pattern inside this. So you first specify on which criterion you are selecting or unselecting a line. Okay, then you specify what you want to do with this selected or unselected lines. And these comments may additionally require one or more arguments. And then you specify file 1, file 2, file 3. If nothing is specified, then std is used. So this is how you need to use set. This is slightly more, I would say, complicated than grep, which is essentially meant for just pattern searching. But here, in addition to pattern searching, this can also do pattern searching in exactly the same manner as grep does. But this line selection criterion may be different from pattern-based match. Okay. And grep does not have a list of comments. It has options, but no comments. So in that, this is the second difference. So you can specify sed what I want to do with the selected lines. And if that comment in turn requires some arguments, you specify that. Okay. And what else? Okay, now if you want to write these comments, command or commands in a file called comment file, then you can run sed as, you give the same options. Now instead of reading the comments from the quoted text, just say -f. read the comments from this file and apply those comments on these files, file 1, file 2, file 3, or stdin. Okay, this is how you run SCD. Okay. Then I will show, I would say summary of what are the selection criteria are and what commands are permitted by SCD. So I will briefly summarize these two things and then I will give examples to illustrate how it works. Okay. So first, selection criteria, selection of lines. So there are two ways: selection by line numbers. Line numbering starts from 1 and then proceeds in the usual fashion 1, 2, 3, 4, 5. The last line is always called $. Okay. That depends from file to file. A 100-line file will have $= equal to 100. A 5-line file will have $= equal to 5, whatever it is, but you can always specify $ to, I would say, tell set that I am talking about the last line. Okay. Okay. And what can you supply here as the selection criteria? Okay, it is this. If it is a single number, then you are specifying you select only this line number. Okay, if that line number does not exist in the file, then no line will be selected. Or you can specify two line numbers separated by comma, m, n. It tells SCD you select lines from m to n, both inclusive. Okay, so all intermediate lines are selected. And you can also say start from line number m and go until the end, last line. So $ is the last line. Okay, so this is how you select lines by line numbers. Okay, you can also select lines by regular expressions. That is, only the lines that match the given regular expression will be selected, irrespective of their line number. Okay. To supply the regular expression within a pair of delimiters, people usually use this /. Okay. And so something like this. Instead of this selection criterion, you just specify this regular expression within a pair of the delimiter /. Okay. And then we will see what you can do on the selected lines. Okay. So here are some examples. So if you just say 20, then select line 20 only. Okay, whatever command follows, this we have not yet talked about. And the next slide, I will give you a summary of whatever you can do. What are the commands that are permitted? 5 to 10, so select lines 5, 6, 7, 8, 9, and 10. And this is another handy thing, $1, It says that select all lines, starting from beginning to end. And finally, this is an example of a pattern-based search, regular expression-based search. Select all lines that start, this caret character at the beginning means start of line, start of the target input string. Select all the lines that start with an uppercase letter. Okay. And if you want to select multiple ranges of lines or multiple selection criteria like this, okay, then you use multiple comments. So I will come to that multiple comment thing later. Clear? Shall I proceed?
Sir, how can we do something like the last 2 lines or last 3 lines?
I do not think you can do it, but you just check something like -2 to $, that is permitted or not. As far as I remember, there is no such option. -2 may mean start from the second last line. So I will just verify whether this is permitted.
Okay, sir.
I cannot immediately remember. Of course, this is a
Okay, sir.
possibility, but I never tried it out. Yeah. So you find out if it is possible, and if it is not possible, it's not possible. Okay, any other query? Yeah, there should not be many queries because I'm just telling you the syntax. It's nothing to understand, really. Okay, so what commands are permitted? So print the selected lines, that is P. Insert text before each selected line. Okay, and you have to specify this text using this kind of syntax, backward slash followed by the new text. You can append text after the selected line. Okay. Again, this is of this syntax. This command is A followed by a backward slash and then the text that you want to append after the selected lines. And you can also replace the selected line or lines by this text. Okay. And delete the selected lines again. I would say I mentioned that it does not actually delete lines from the input file. Okay, but it prevents these lines to go to the output file or to std out. Okay, so delete does not mean delete from the input file. Delete essentially means delete from the display. Okay. Print, insert, append, change or replace, delete. And this is an important and interesting thing. You can substitute a pattern by a new string subject to certain options that I will see later. Okay. So this stream editor, possibly this is the most useful feature of the stream editor. You can mechanically supply commands and make a substitution, regular expression-based substitution of patterns by new strings. So substitute pattern by new string in the selected lines. And these additional options we will see. Okay, substitute the regular expression that you supply here, and this will be replaced by whatever you provide here. We will see examples and options. There are 2, 3, 4 options. We will see. Possibly this is the most useful feature of ACT. Possibly, I would say, of course. And Q means quit after the selected lines. And these are things, of course, I am, for the sake of completeness, I have inserted these things. So insert the content of in file after the selected lines and write the selected lines to out file. Okay. So maybe I will explain these things. R and W you can read from this set of slides or from other online or offline material. Online, okay. So, resources. Okay, so printing the selected lines. Okay, something will happen here. Let us. This will actually explain another option for ACT. Set always prints the input lines. And of course, after substitution or something like that, whatever you ask the editor to do, it does that and it always prints that line. Okay. And if you say P, this option P, print the selected lines, all the lines are anyway printed. So the selected lines will be printed twice because you asked for an additional printing. Okay, So what is the use of this? And you will see. So if this print, always printing this pattern, if you want to inhibit, you should run this with the -n option. So it essentially says, do not print unless I ask you to print. So -n stands for please do not print unless I explicitly want you to print. Okay. So once again, if I look at that example, all lines ending with non-alphabetic letters will be printed. But this I did not run it with the -n option. So anyway, it will print all the lines. But those lines that are actually selected by this regular expression are printed twice. The first printing is because of this default print behavior, and the second is because of my explicit instruction that print it. Okay. If I run this with the -n option, then this default printing will be stopped. Okay, so let us do this. So if I said do not print by default, print only when there is a match. Then you can see only the lines that match, that do not end with alphabetic letter. This, and this. So you are essentially asking set not to do the default printing. And you can also do something like this, set -n 15p, print only the 15th line. Okay, no other line. Okay, -n prohibits set to print its, follow its default printing behavior, and print on the lines starting from 15 and ending at 20. So 15, 16, 17, 18, 19, 20. Okay, and another thing you see, tell, if you have a question.
First one, we are not mentioning the line number. Even then what will be the behavior?
No, all the lines that match this pattern will be selected.
Okay, so like can't I mention that within these set of lines, all the lines that match this pattern? Isn't there any option like that?
Let me see. What is that? It's I think you can supply multiple comments, and now it will be, is it and or? Well, you can handle this using that substitute command. First, select the lines using line number, and then inside that, if the regular expression matches, then you print, otherwise do not print. Yeah, that way you can do it. So let us look at that substitute option. Do not substitute, just keep it as it is, but print it. That way you can do it. Clear? No, not yet clear.
Okay, sir. Means I don't know. Did you discuss about substitute command?
I just briefly told about it. I'm coming to that. How to use it. Okay, this is fine, right? So I'm always running with the -n option to stop the default printing. And I specifically print those things that are selected. Selection may be based upon regular expressions or line numbers. Okay. Okay. And these are some simple examples. Insert and appending. So you say I want to insert the line, a new line. But the selection is line number 3, line number 4, line number 5. And you see that this is line number 1. I am not writing it with the -n option. I want to see that it has done the correct thing. Okay. Otherwise, it will not print any of these lines. It will only print a new line, a new line, a new line. That's not a good thing. So maybe it's there in the next slide. So it inserts this a new line before 1, 2, line number 3, line number 4, and line number 5, and nowhere else. And appending is similar. Instead of inserting the line before the selected lines, it will simply say after. So 3 to 5 append means a new line. 1, 2, 3 after line 3, this will be printed. After line 4, after line 5, and after no other line. Okay. Okay, so there is not much to understand. And you can see that if I just prohibit this default printing behavior using -n, then you can see only the new lines. The original lines will not be printed. And this is an application, you can say. This application is something like double spacing a given input file. After every line, append a new line. Okay. So this is a application in double spacing the input. Okay, so we will see later. So this was my line 1, line 2. No, line 1, there was a blank line already. Line 2, this is line 3. So how many blank lines will appear here? 1 for that thing, 1 for that blank line. So 3 blank lines. Okay, so that does look very good. So we will see. I will keep this paragraph type of behavior. But something. Yeah, we will see. So this is an application where I am double spacing the input. Agree or not?
Sir, can you explain once again why is there more space between abstract and this?
Look at this file. Oops, yeah, this is the input file actually. So after this line, it will add a space. After this,
already there are 2 spaces.
Yeah. So there will be a total of 1, 2, 3 spaces, 3 black lines.
Okay.
Yeah. Yeah. Okay, so it's not necessarily a single line. If you can use this a new line, \n, a second new line. That way you can specify multiple lines using this -\n option. Okay, anyway, that's not an important issue. These are simple things: inserting and appending, replacing. This also illustrates this \n option. So we replace line number 3 to 8, change it by this new line, followed by another line, another new line. So 3, 4, 5, 6, 7, 8. So 6 lines are replaced by this, and then this will be followed, whatever is there. Okay, so this is C, change. And how you can add multiple lines using this backward \n thing, escape character. New line, another new line, then the old thing. Just from line number 9 onward, old thing are printed. Okay, so C stands for change. Deleting, and very similar thing. Delete line number 3 to 8. And then do the usual printing business. And again, note that deletion does not happen from text file.txt. It's only deletion from printing. Or if you send this printed line to an output file, the deleted lines will not be printed. Okay, so straightforward things. Now, this is the most important thing, perhaps. So pattern substitution. So it is something like this: substitute pattern by the replacement string subject to certain options. Okay. A pattern is a regular expression I have already talked about. Replacement string may be a constant string, or it may be a function of the portion of the string that matches. Okay. And that match string can be addressed by this special character AND. Okay, so if you simply say substitute pattern by AND, then this is followed by the options. It's basically not a substitution. You are finding it, replacing it by the same thing. And that, I think, addresses a previous earlier question raised. Select lines based on line numbers. Find this pattern. If it matches, do not replace it. Replace it by the same thing and then here option, as an option you can say print. Okay, is that earlier question answered?
Yes, sir.
Okay, good. But of course, if you want to replace pattern by same thing, what is the use of this, except for answering your query? So, for example, if I want to uppercase this pattern, I can, for example, use this special command uppercase AND, or lowercase convert this AND to uppercase or lowercase. So this should be followed by AND, this will be followed by AND. Okay, or it may also be some constant string. For example, I do not know, many students used to write definitely lost. Okay, it's not definite, it is definite. So if you want to, for example, make this special, this spell correction, and in your file, you will search for this definite, replace it by definite. Okay, this is another application, perhaps, spell correction application. Okay, one or more of the following three options. Now, what about the options? I will come to examples illustrating how to use this. Okay, but let us see what are the options. There are 3 or 4 options, I believe. P is print the replaced strings to std out, and this printing will happen. You did not ask to print because this is not a print command. Okay, so you have to supply the option print here. Okay, this is not a print command, right? But you can print it if you give this option P here. Okay, if you run it with -n, then only the lines that match after the substitution, that line will be printed. Okay, and then this is called global. If you just say this, it will make a single substitution and we'll be happy. Okay. So substitution is made only once in each selected line. This is the default behavior. But if you supply the global option, then it does not stop even after a single replacement. So it will try to make all possible substitutions in each line. Okay, we will see examples. And write to out file, write the substituted lines to out file. Okay, so this is the anatomy of the substitution command. S followed by the regular expression called pattern, followed by a replacement string, which may be a constant string or some function of the pattern, followed by one or more of these options, or 0 or more of these options, P, G, W, out file. Okay. Okay, let's see examples. Okay. So what do I want to do? On my text file.txt, let's say I am just like that spell checking thing. I just want to replace this single minus by double minus. Okay. So I am selecting lines that contains this. Okay. And then I once again searching for this pattern, and here I know that there will be a match. But you can also select $1, and then substitute. Okay. And I am not running with the option -n, so it will anyway print everything. Okay. Yeah, you see, this line does not match, so it will anyway be printed. And this matches, so this minus is replaced by double minus, and it is printed after substitution. Okay. And if I prohibit this default printing behavior by -n, then nothing will be printed because I have not asked this print directive here. But if I write this print directive here, then only the lines that match substitution happens, these things will be printed. And if you now look at this, if there are multiple occurrences of minus, only the first occurrence is substituted, like here. There is a substitution only once, but this is not substituted because I have not supplied the global option. Here also you see, first substitution took place, but this one and this one did not get substituted. And if I want that, I have to additionally supply the G option, global. So I think that is the next example, yes. So if I run the same thing with the global option, then you can see this is substituted, this is also substituted, this is substituted, this is substituted, this is substituted, and so on. And this is something that illustrates write to out file matched.txt, and if I say cat matched.txt, I will see. I do not print anything, but all the output, this output will go to the matched.txt, which I can later see like this. Yeah, any queries? No? Okay, let me proceed. Here are some applications of the substitution operation. $1, mean in all lines substitute dot star by the uppercase of this. I do not have to supply the global command. Why? Do you remember? Dot star means what?
All.
Oh, sigma star basically. But then why I do not need to have this global option here?
So dot star will correspond to the whole line.
Why? Why not character by character?
Sir, because we will take the largest one.
Largest, yes. So that is the philosophy of patterns, right? Regular expressions. Leftmost, largest possible or widest possible match. So that is the entire line. Therefore, I do not need to specify any global option here. And you see, it is uppercased, converted to uppercase. Okay. So this is one method. select all lines irrespective of whether something matches or not, and then make this substitution. Okay, convert the pattern, the searched thing, to uppercase. Now, if I want to, instead of dot star, if I want to do this thing, substitute a lowercase letter by an uppercase letter, the corresponding uppercase letter, I can use this. But here I am making a character by character search. It is no longer dot star, so it's just a single character that matches. Okay. Therefore, I have to specify this global option. Agree or not?
Yes, sir.
Okay, and anything else which is not a lowercase character, lowercase letter, that will remain unchanged. Okay. And if you just run it without the -n option, then this will be printed, including the blank lines will be printed. Okay, because you didn't prohibit the print behavior, default print behavior. But if you just run it with -n and give the print comment here, okay, global replace, and then print, then it will not print these lines, for example, where no substitution actually takes place. Okay, so that's the difference between sed and -n. Giving a p or not prohibiting this p here, prohibiting this here, you are printing explicitly by this p. So that's the difference. Okay. Okay, so this is another way of doing it. Here it's a single substitution of the longest possible match, and here you have a character by character substitution. Okay. Okay, premature quitting. So this says that line number 5 matches, after that you quit. Here you say quit immediately after the line that ends with a non-alphabetic character. So this is found and then quit. This is line 1, 2, 3, 4, 5. After that it is quit. Okay. I would say this inserting an input file and write selected file, you just read it. Nothing so special about it. Okay, now how to negate a comment. Okay, so let me understand. Do you have any queries?
Sir, can you please explain that dot star thing, sir? I didn't get what you said in the end.
This one? This one,
Yes,
right?
sir. Yes,
Okay.
sir.
So what is the command? Select lines based upon line numbers. $1 to $, means all lines.
All lines.
Okay. That is the selection criteria. You may or may not follow it by a space. And then what is the comment? Substitute the entire line by the uppercase version of that thing. Dot star matches many things. If I look at this abstract line, capital AB matches this, capital ABS matches it, STR also matches this. Okay. But the philosophy of regular expression is that the match should be as wide as possible, starting as early as possible.
Okay,
Therefore, dot star essentially stands for the entire line. Of course, if you are considering caret, dot star, $, you simply force the match to start at the beginning of the line, and $, means you're forcing the match to stop at the end of the line. But it is not needed because of the philosophy of regular expression matches. It's widest possible, starting as early as possible. leftmost widest match. Okay. So this is what we are utilizing, this philosophy of pattern matching. And here I am in much more bigger control. I am just replacing individually lowercase letters to the corresponding uppercase letters. It has the same effect. Okay.
Yes, sir.
Okay, good. Okay, few other things. Maybe I will take another 15 minutes or so. Negating a comment. So this is denoted by printing a not. This is like C is not. Okay. So actually all these things are developed more or less together. The C language, the Unix operating system, along with this basic, I would say, Unix commands like sed, grep. So there is some commonness in all of this. So this is like this. So which lines are selected here? 16 to $. These are the selected lines. Line number 16, line number 17, line number 18, and so on until the end. And by not P, you are saying that do not print those lines. Print all other lines. So the action in the command is taken on the unselected lines. The lines that are not selected using this selection criterion are the lines 1 through 15. You're asking print only lines 1 through 15. That's what you can see. 1, 2, 3, 4, 5, 6, and 15 lines. Starting from line 16 to end will not be printed. Okay. Okay, I think. This is another application, print lines not containing that hyphen or minus sign. If this is selected, if a line matches this pattern, do not print it, otherwise print. You can see all the lines in that input file which does not contain this minus sign. Okay, so these are just some simple small examples. This is an important, another interesting thing. So I want to double space a line, double space the input file. But if the input line already contains a, what would I say, blank line, I will not append a blank line after that. So if I have a blank line here, that means there will be one or two blank lines here and one blank line. So this is double spacing. And instead of 3 blank lines, I will have 2 blank lines between paragraphs. So this is this. Okay. And this is, what does it select? This is beginning of strings, end of string. So it will, I would say, select only the lines that are completely empty. Of course, if you want to do, I would say, allow spaces, then you have to do something like that, like space star, something like that. Okay. And if you find a line which is completely empty, then do not append this new line. But if you find something like this, which is not an empty line, then you append this. Okay. So this will not give you 3 empty lines here, but only 2. Because it will not append new lines after an empty line. A simple application anyway. Agree or happy? Okay, maybe happy. Okay, so maybe this is the last topic. How to run multiple commands. Okay, you select certain lines, do something, and if you want to process those lines further, one possibility is you use semicolon to separate commands. Okay. But there is a problem. The semicolon can be a part of a string. I will illustrate this, what I mean by this, during insert, append, or change. Okay. So, like grep, you should specify each command with the option -e. And this is actually AND. Okay. So the commands are executed in the sequence in which they appear. The order of the comments therefore may matter. And another option is to write all these comments one after another in a file and invoke std with the -f option. Okay, so let's see what it says. It says that this is the, I would say, composite command. Print lines 3 and 4, print line 8, quit after line 9. And this is not run with this -n option. So by default, everything will be printed. So line 1 is printed, 2 is printed, 3 and 4 will be additionally printed second time. This and this. Line number 8 is also printed a second time. Then line number 9 is printed, and since this is the Q command, after this, it will stop, terminate. Happy?
Yes, sir.
But as I told you, if there is a line that contains uppercase letters, okay, then I append substitution made above, and then I actually want to start a new command by semicolon. The second selection criterion is those lines, which is basically the same as this selection criterion, maybe different, but in this example, this is the same. If a line contains one or more uppercase letters, replace those letters by their corresponding lowercase versions and do it globally. Okay. And if I now run this, we will see something like this. Semicolon is no longer a command separator. Said actually thinks that whatever follows this is the replacement, I mean the appending string. Okay, so it will do something like this. We'll consider this thing as part of this expression. So it will keep on printing this, this, this. More importantly, it will not make any substitution. Capital A remains capital A. Because this is treated as a part of the string. Understand? So no substitution actually takes place. Okay, but this can be avoided if I use -e twice. Okay. So if I say -e this, then again -e this, then these are now clear to the editor that this is one comment, this is another comment. Now you will get the desired behavior. Substitution made above. So the substitution actually happened. Uppercase A has become lowercase a. Uppercase T has become lowercase t, and so on. Okay. So minus E has some role to play. The semicolon always does not work. And if you look at this line, for example, public key including blah, 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 there are no uppercase letters, so this is not executed. Okay. Now, it's an interesting thing. What if I simply swap these two things? I first write this comment and then this comment. What will happen? Any guess?
Sir, first it will convert to lowercase, then the second command pattern will not match itself.
Exactly. So after this substitution, if this is checked, this will never match. So these lines will never be printed. Okay. So be careful when you utilize this minus E, multiple minus E options. You always remember that first this thing will be made, will be executed, then this will be executed, then if other minus I's are there, okay, those will be executed. Okay. So the order matters. Because after global substitution, no line contains any uppercase letter. Okay. And this is another example. You say if you find a line containing this single hyphen, replace that by this globally, and then quit. So it says first substitute, then quit. Okay. If I simply swap these two things, you say whenever you find this, quit. And after quit, you substitute. After quit, you cannot substitute, right? Makes no sense. So you do not see that minus minus here. Agree? So the order matters. Don't forget. And yeah.
Sir, when we write minus E command, then first one is executed throughout the file, and then the second one starts.
You have a selection criterion here.
Yes, it means all that means in the file it will select all lines with this dash, then it will replace with dash dash, and then we say dash quit. So the first dash that it finds in the whole file, there it will.
That will also match. Okay. So we make this.
So there it will quit.
Line changes to this, and then you say quit. But here you say that whenever the line matches has a single hyphen or minus dash, print it and quit. Print is the default behavior, of course. If you run it with minus and then this printing, you will not see. And then you say you quit and then make this substitution. That makes no sense. This has no effect on that line. It is exactly similar to this. After global substitution, no line contains any uppercase letter. And therefore, the second command will not be executed.
Sir, in the first one, if we write GP in the first E, then what will happen?
Another thing will be printed. Same thing will be printed another time. And here, if you say GP, this will not be printed because before that it has quit. You asked it to quit and then substitute.
Oh, okay, sir.
Okay, it will not print it. This print will not be executed.
So, sir, like in the first example, are all dash substituted by double dash, or like as soon as a line in a line, if you find that the dash is present, then it will substitute and then quit.
It depends upon this option. Here I have given the global option. Right,
So
G stands for global.
yes, yes.
If I do not give this global option, and if there are multiple minuses or hyphens there, then only the first one will be replaced, substituted.
So, sir, like the first command is executed on the entire file first, and then we go to the second command. Is it happening like that?
No, line by line.
Okay, so let us say a line in a line, like
Line number
we
one.
execute the first command.
Yeah, I will see if this line number one matches. If it matches, this command will be executed. Then you will see if line number one matches, then this command will be executed, and so on.
So if in a like in one line it matches, then we are quitting. So in the lower lines, this replacement of dash by double dash will not take place.
What happened? You told it to quit.
Okay, okay, sir.
Whatever you instruct, it will do.
Sir, so global is with respect to one line, right? Even global does line by line.
What is with respect to how many times you substitute? This is with respect to a single line.
Okay, okay.
Yeah. Any other question? Yeah, more or less this is the thing. The only thing, there is a small thing. You can write the set comments in a file. For example, replacing all uppercase letters by lowercase letters. So these are this time the selection criterion was different. If this is if there is a lower uppercase character and uppercase character, then first you append, then you actually replace all the things globally, all uppercase letters. So you can write these two comments instead of using this minus e this, minus e this. You can write these two comments in a file, txt or comments. Yeah, ACD, they are
Sir, we are first finding the capital letters and then substitution made above.
Yeah.
And then we are doing the lowercase thing. So, sir, why does this S is not getting lowercase?
This is a new line. This is a new line. This is not part of the input file. This is what you are adding. This thing does not happen.
But
This
it
thing
should
does
be
not
counted in the next line.
No. This is not part of the input file.
Okay. Yes.
Okay,
Got
so
it,
you
sir.
can write this thing in an output file and once again run this ACD on that as an input file. Then this will be treated as an input line. Okay, here it is not treated as an input line.
Yes, sir. Got it, sir.
Yeah. Okay, so you can write these comments one after another. These are small examples, but you may have 100 processing tasks on lines with different, potentially different selection criteria. And simply say, instead of I am not supplying you these comments in the command line, but you just read it from this text file.txt, and this is the thing. And there is another way of doing this, is what you will eventually have to understand: writing a script, writing a ACD script. Okay, so we will do this kind of scripting thing more frequently than what we have done earlier. Okay, so you write the lines in some file. Okay. First of all, you use this which command to find out where this SCD command is staying. Which SCD, you see that it is in user bin. Okay. Then you write a file. In the first line, this is an important thing. This is called the hash bang or the shebang notation. You will later change the permission to 755, means that it is an executable file. 755 means read, write, execute, read, execute, read, execute. So you're supplying it execute permission, right? But this is not an a.out like a file. The first line, which is called the hash bang or shebang line, it says which command interpreter I should use for running this remaining things. Here it says it is SED. User bin SED you have to use with the option minus file. That means these things will follow. Okay. Then you line these things, write this. So this is basically a text file. And I would call it an SED script. For the rest of this course, we will keep on writing some such scripts. In the next class, we will see how we can write awk scripts. And after that, for 2 or 3 lab sessions, we will see how we can write bash shell scripts. Okay, this is not an a.out kind of file. You have a set of instructions, and the first line, which is called the hash bang line, will tell the interpreter that will interpret the rest of the lines. Here it is SED, and these are the commands. Then you change mode, give it execute permission, and then simply, instead of /a.out, you say /commands.sed textfile.txt, and whatever is supposed to happen will happen. Okay. So I think this is the last slide of SED. Okay. Apparently there is supposed to be a question, but it just ended up in a noise. Okay, so this is called a script file. Commands.sed is a script file, and it is an SED script, sed script. First line says which interpreter I should invoke to run the rest of the commands. Okay, you will see more and more examples. In fact, all the future examples, or if not most of the future examples, if not all, will deal with some such scripts. Starting with a hash bang line, followed by instructions that interpreter can understand. Happy? Yeah, I think we should stop here. AWK is something little bit subtle, quite different from SED or grep. It's basically a full-fledged programming language, C-like, but it has its own features. And it's essentially designed to handle text-based database files. So we will do it in the next class, because it's already 2 things you have seen. Another thing maybe too much. Yeah, so let me stop presentation. Yeah, so tell if you have any questions.
Sir, can you go to the previous slide where we were substituting and then quitting that one? Yes, sir.
Yeah.
So here you said that when we write.
Yeah, Del, what is the
Sir,
question?
when we are writing, when we substitute well, like when we append a line, then it is not a part of the input file. So after that, if we write the command of finding capital letters, it won't detect the lines that we have added.
No, I didn't understand your query.
Sir, so it's not actually this slide, it's the next one, I think.
Oh, it's previous one. This one?
Yes, sir.
Okay, good.
Sir, here first we are saying that whichever line has a capital letter, write this line substitution made above,
Yeah.
next after that line.
Yes.
And then in the okay, sir, I got it. Sir, I got it.
Yeah. Okay. Yeah. Only thing is that this is not part of the input file. This is
Yes,
not
sir,
a
it is executing line by line, so this is not actually a line.
This is not a line. Yeah.
Yes, sir. And sir, I have another doubt. Sir, if we write -n and then inside we write $1 to $, and then P.
Where?
So, no, sir, it's just a general doubt.
Another -e.
Yes, sir. So outside we have -n, so it will not print the input lines, but inside we have $1 to $, and then we are writing P. So it will have the same effect as writing just $1 to $.
Yes, same effect. Yes. Okay, so any other queries? Okay, so I would suggest that you take some text file and run ACD and exercise different options, selection criterions, different types of things. And whatever I tell, this will not make the entire thing clear to you unless you experiment with this. And that has been true so far also. If you never run Valgrind, just by reading the slides, you will not be able to fully understand its working capabilities and so on. You have to write some files. You have to run GDB. Okay, so this is a practical laboratory. So are you doing this?
Yes. Yes, sir.
Okay, good. If you are doing it, good. If you are not doing it, then I don't know. This is not a theory. Nothing of this is a theory, right? How to use something, whether it's a debugging tool, whether it's a profiling tool or some scripting thing, you should go ahead and try. I cannot tell you everything. So please do it. Okay. So welcome to scripting. So from next day onward, we will write only scripts, Gawk scripts, Bash scripts, and so on. Okay, so shall we call it a day? Okay, then I'm stopping sharing. And if AG wants to add anything,
No, there is nothing. First lab after the test week, so that will go on for some time.
Yeah.
So we have said most of the things so far. We should be, publishing your marks sometimes by end of this week. It's almost 95% done. Small work left.
Okay. What else?